Hey guys, we are here for packet 7, right? So it looks like we answered each of these questions and we learned about altitudes make orthocenters, medians make centroids, angle bisectors make incenters, and perpendicular bisectors make circumcenters. All right, so it looks like we did all the questions on this page. This page was left blank and this page was answered. Okay, so we just have to focus here. Now let's think about what formulas we have. Okay, so we know that, I'll just use this area here. We know that the area of a circle is pi r squared. So the area of like just a quarter of that circle would be 1/4 pi r squared. So we know that this angle 90 happens to be a quarter of 360. So this reminds us that if we know this central angle here, then the area of a section or sector, the area of a sector would have to be the central angle over 360 times pi times the radius, okay? Now, what if instead of a part of a circle, you wanted a part of the circumference. So if all the way around is their circumference, pi times diameter, or 2 pi r, right? What if instead of all the way around, you only wanted a quarter of the way around? So that is called a arc length, right? So our arc length, right? Sometimes it's called S. Our arc length is equal to, that's 90 degrees, right? The central angle divided by 360 times my circumference. So this was our area, right? So now I'm just going to say pi times diameter, right? That's the portion of the circumference that we want. Make sense? All right. Now, if we converted this to radians, then our arc length S is equal to theta times r. It simplifies it. All right, I think that's everything we need, right? Okay, so let's do it. So let's pick a question here. All right, this is the area of this sector. So I want to know this area of that sector. So let's see, the area of the whole circle would be pi r squared, and the radius is 8, so the area of the whole circle is 64 pi. Okay, so I want a portion. I want 42 out of 360 times my area, 64 pi. Okay, so I have to figure out, looking at these numbers, what fraction that would reduce to. There's a couple ways to do it. Probably the fastest way, if I have a calculator, is figure out what this decimal is, what this decimal is, what this decimal is, and what this decimal is, right? And compare it to what this decimal is. All right, so what is 42 times 64 over 360 as a decimal? 42 divided by 360, clear that, 42 divided by 360 times 64. All right, so I get 7.46 repeating. Okay, so 7. This is 7.46 repeating pi. So which number would be 7? Can't be that one because that's less than 1. Can't be this one because that looked like almost 2. So 49 divided by 7. So it looks like it might be one of these two. Sorry about that. My hand opened a different page. So let's look at 60 divided by 7. 60 divided by 7 is 8.57 times pi. What's 112 divided by 15? 112 divided by 15. That's our number, isn't it? You see that? Okay, so our final answer is this one. because this fraction is also 7.46 repeating. Okay, now what would be another way to do this if you didn't have a calculator? We could reduce this fraction. Okay, so we know that these numbers on top are even and that number on the bottom is even. So we can divide the top and bottom by 2. Okay, so we get 21 times 64 divided by 180. I divided the top and the bottom by 2. Now notice these are still even, so we can divide this number by 2 and this number by 2, right? 21 times 32 divided by 90. All right, they're still even, aren't they? So we can divide by 2, divide by 2. So we get 21 times 16 divided by 45. And now you're starting to get close to this number. Notice 45 is 15 times 3. So if I divide by 3, and I can divide by 3 by 21, and divide by 3, I get 15. 21 divided by 3 is 7, so 7 times 16. Guess what? 7 times 16 is 112. So that's another way to get that answer, reducing fractions. Nice. Okay, let's look at question number 2. It says in circle Z, the measure of PZR is 2 2/3 pi. Okay, so let's review what a radian is. A radian is all that would be pi, and all the way around is 2 pi. Why? Because we define circumference as 2 pi r. So we define all the way around as 2 pi radians. Okay? So any circle, specifically our unit circle, has a circumference of 2 pi because all the way around is 2 pi radians. And radians is what we use as our unit of measure. Okay? So this is pi, and this is 2 pi, meaning this is pi and another pi. So all the way around is 2 pi. Okay. So can we find the length of PR? Sure, we said that S is our arc length is theta times R. So if theta is 2/3 pi and R is 8, then we simply multiply these, right? So we can have our pi. We have 8 times 2 in the numerator and 3 in the denominator. We found our answer. So really, is that it? Yeah. All I do is take our angle and we multiply it by our radius. Got it? Next one. Question number 3. In the diagram below, the circle shown has a radius of 10. Okay? And the angle intercepted by the arc with the length of 2 pi. All right, so here we think about 2 pi as the number 3.14. So it's simply said, however units long, maybe it's centimeters or millimeters, then it's about 6.28 units long. That's how long that arc length is, okay? Now, the angle B intercepted arc with a length of 2 pi. What is the measure of angle B? Okay, so they want to know what this angle is. That's our central angle, right? So we know that our arc length, S, is equal to theta times R. So if our arc length is 2 pi, theta we don't know. We can call this B if we want. You can change this to a letter B. And our radius is 10. We can solve for B by dividing 10 on both sides. What do we get? We get the measure of angle B is pi over 5. What do we see? Pi over 5. We good? Okay, let's try another one. 5, the area of the shaded part. So this is very interesting. Notice they shaded not this piece, but the part left over here. Okay, so we could say that the area of the shaded equals the area of the whole circle minus the area of the unshaded. Okay, so this is this basic idea. So if I knew the area of the whole thing was 60 and I knew the area of this was 10, then I would know the area of the shaded would have to be 50. Basic idea here, right? All right, so let's start out here. It says, what if the area of the shaded part is 15 has pi, what is x? Okay, so we know that the area of the whole circle is pi x squared because we're using x as r. And we want a portion of it. So what is this? Well, 360 minus 60. That means I want 300. So the area of the sector is 300 divided by 360. This has to be 300 degrees times my area, which is x squared r pi, right? Pi r squared, and the radius is x. So now they're telling us if the area of the sector is known as 15 over 2 pi, then can you get x by itself on one side? Using this equation, we can. Okay, so step one, we're going to divide by pi on both sides, and it goes away, so that's nice. So just kind of copying down our equation here. We know we could multiply by 360 on both sides and this would go away. We know we could divide by 300 on both sides and that would go away. So what I ended up doing is multiplying the reciprocal on both sides. Okay, so now we get this equation. So we can multiply numerators and we can multiply denominators. So on the top we have, or the bottom, we have 300 times 2, which would be 600, right? And on the top we have 360 times 15. 360 times 15. We get 5,400. So we want to find out x squared is equal to 5,400 divided by 600. Divide by 600. We get 9. Ooh, that's nice. That means x is 3. Well done. So we could check our work. I'm not going to, but we could. And we could plug in here. Well, if the area of the shaded region is 300 divided by 360 times pi, 3 squared would be 9. Is this fraction the same as this fraction? And it should be. Okay? All right, question number 5. We took some notes down here, so let's just section this off for ourselves. Okay? Question number 5 says, an arc on a circle of a circle of radius 10 has an arc length of 49 pi over 9. What is the measure of the corresponding central angle? Okay, so we don't know the central angle, but we know the arc length is 49 pi over 9. What is the measure of the corresponding central angle? So we know that our arc length is equal to the central angle over, it looks like we're just measuring here by 360 times pi, radius squared is 100. And we know the arc length is 49 pi over 9. Okay, so notice we can solve for that central angle. Okay, so we end up getting pi's to cancel. 10 times 10 is 100, right? So we end up our central angle equals, I want to multiply by 360 on both sides. I'm going to divide by 100 on both sides. And that goes away. So I only have the central angle on the left because 360 canceled. Now on the right, I have 49 times 360 divided by 9 divided by 100. Okay, so we can figure out what the central angle is. That would cancel. This we could divide by 2. Again, you can just do this in your calculator, but it would be 18. And then that would be 5. Notice I could cancel this. Divide by 2, divide by 9, divide by 9. 4 times 2 over 5. So I get 8/5. 1.6. That seems weird for an angle. So maybe I should have used radians. So let's try this again. S equals theta times R. So if the central angle is theta, if I divide by R on both sides, I know theta is equal to whatever the arc length is, divide by R. So I need to just take this, 49 pi, divide by 9, divide by 10. So if I multiply by 1/10, I end up getting, right, for my angle, 49 pi over 90. All right, if the radius is reduced by 2, is the arc length still possible? So let's look at that in our picture. So if I take my magic pen, if instead of 10 I put 2, does it make sense that that arc length has to get smaller? So if my radius is 2, is my arc length still possible? No, my circle got smaller. Okay, last question for the day. It says, question number 2, given there's 3 concentric circles, so concentric just means a dartboard, meaning they share the same center. Given that there's 3 concentric circles and being told that KL, this length, is equal to this length, is equal to this length. So it's definitely a dartboard. Those distances are the same as you go out. Okay. And that the whole distance, KP, is 42. Then we notice by bunny hopping 1, 2, 3, 4, 5, 6, that if I divide by 6, I get 7. So I know that the distance of each of these is 7. Okay? What is the area? Well, the area would be the radius pi r squared, right? So the area here, the radius would be 7 plus 7 plus 7, or 21. Okay, so what's the area of the shaded region? This takes a little thinking. Okay, so I could say the area of the shaded region is the whole thing, pi 21 radius squared, right? But then I have to divide by 2 because I don't want this whole thing, right? I want to erase off this part. Okay, so that's what this is. I took the whole thing and then I divided it by 2. So then though, they got out their eraser again and they erased this little part. Notice that? So I have to figure out what this little part is so that I can take that out of there as well. So I need to know the center circle, so that would be the area of the little center circle is 1/7. So pi 7 squared divide by 2. So I need to subtract pi 7 squared divide by 2. So what's the closest area to this region? They said we just need to find it out. So we can crunch this all on our calculator. So pi, or 3.14, times 21, times 21, divide by 2. Okay, 69237. 69237. Now we're going to subtract off this part right here that got cut out. So pi 772. So 3.14 times 7 times 7 divide by 2. 7693. 7693. So now we're going to take this and subtract it from there. So 69237. 69237. Right, so 615.44. 615.44. 615.44. That's the closest answer. That's it, guys. Thanks for joining us.